Good evening. Apologies for not speaking French at all. My name is Pini Resnik. I'm from normally it works fine with Sync, but in French it's spelled with Crescent. General idea of the company that when we started, it was all about sustainability in IT. So helping businesses to reduce emissions through different means, but normally building proper platforms and all kind of different things. Yeah, so we started about a year ago, and we have very long history of basically working with large computer systems, and we saw how much waste exists in those systems. I'll sort of talk about that. Today I'm going to sort of generally speak about sustainability in IT with focus on AI. First, a question. How bad are bananas? What do you think? Like bad, okay-ish, amazing, in terms of emissions and sustainability? Just a guess if you don't know. Okay. They're okay. It's a safe answer, right? They are okay. It's in the middle. I'll answer the question at the end, but this is a book that it's called How Bad Are Bananas? Which basically goes into different things that emit carbon emissions, and basically measures for general idea how much we emit day to day. It's a very useful book if you care about emissions or sustainability. Right. Okay. So, is the climate really changing? Anyone thinks it isn't? Anyone thinks it is? Okay. It's a sustainability week, so it's very unreasonable. But I had this story once in sustainability conference. Somebody approached to me and started preaching about how terrible all this sustainability thing, and it destroys the world, and we should use more oil. Very, very interesting experience. Normally, I assume people come here to understand why, but what to do about this. So, the scientists say that climate is changing. Now, I'm not a scientist. I rely on scientific data and not political views. So I assume that it's better to do something about it than not. And generally, higher the temperature gets, worse it's going to be for us, right? If it remains below 1 or 2 degrees, 1.5, 2 degrees increase in temperature, it's sort of okay-ish. If it goes up to 6 or 8 degrees, it will be very terrible, like properly terrible. And I'm not going to go into too much detail into that. But basically, to keep it below 1.5, 2 degrees, what we need to do is to go all the way down in emissions within the next couple of decades. And there are sort of 2 major elements to that. First, we actually need to go to almost no carbon emissions or carbon neutral. But we also need to reduce the amount of the emissions we emit until we get there. Today, we are emitting about 54 or 5 billion tons of carbon equivalent every year. By the way, this drop in 2020, what do you think it is? COVID. It's COVID. Yeah, it's 5% decrease, which was immediately compensated the year later. Generally, the world is going still up on emissions, but all the richer countries go down, including France. France is going down. Actually, France went down much sooner, much earlier than everyone else, mostly due to nuclear energy. But all the other countries, all the richer countries go down. China is sort of peak, but other countries like bigger ones like India or Brazil or others, they're still going up. So we're still generating every year more and more emissions, despite the fact that Western world is actually decreasing the emissions. The reason we are actually going down is mostly because we are replacing carbon carbon-based energy with renewable energy. About last year or two, actually the increase in carbon-based energy stopped. So it's now starting to decrease. Actually, the solar and wind are now cheaper, and the generation of those or installation of those sources actually becomes faster than the need for energy. So the expectation is that somewhere in the next 15, 20 or so years, we will entirely eliminate the oil and gas and coal. Last week, UK actually stopped using coal altogether. They shut down the last power plant using coal. So this is very high level, right? Now, what's happening in IT? There's many different estimations how IT is doing and how much IT is actually contributing to emissions. But the general agreement is anywhere between 1.5 to 3 gigatons of emissions, which is anywhere between 2 to 5, 4 to 5, 6% of total emissions of the world, right? Between 2 to 5%. And that's problematic because assuming that, we can expect the demand on IT to grow, to double and then quadruple and then go tenfold in the next 10 or 20 years, mostly because of digitalization and AI. But we need to reduce our emissions to almost nothing in the same time. So there's clearly, the demand on IT is going up, but the expectation that we reduce emissions to almost nothing, there's definitely a big gap. So unless we can detach ourselves entirely, so our value, IT value that we produce for our customers, entirely detached from carbon emissions, we will not achieve the goal of reducing the emissions to the point that we actually keep the Paris Agreement goals. So this is definitely a challenge, right? So if this red line again is carbon emissions, so this is assuming that we can keep the 1.5 to 2 degrees of increase in temperature. Now, what it actually means carbon emissions, like how we actually generate carbon emissions, there are 3 ways to do that. The first one is energy. Yeah, obviously we consume energy on compute. The second one is hardware. So it's called embodied carbon, which means how much carbon was emitted while producing the device itself, or buildings around the device, or all kind of other things. And the last one is carbon awareness, meaning how we can shift the loads from place where there is high carbon intensity to places with low carbon intensity. For example, move from Poland, where most of the energy is generated using coal, to Nordics, where most of the energy is generated with hydro. That would be carbon awareness. Or adjust the needs of, or adjust the execution of our loads to the availability of greener energy, basically. Yeah. And there's no expectation for everyone to immediately become super green and stop emitting, right? Because we do have time, right? We don't have a lot of time. We should start as soon as possible, but we do have time, and no one is expecting any meaningful company to just stop emitting. It's just not practical. So there is, this is one of the artifacts from Green Software Foundation, which is the Green Software Maturity Matrix that basically suggests a step-by-step process of becoming greener over time. And the first step is basically just measure and be aware of it, and then gradually invest in more and more in actually reducing it. And about carbon awareness, so this is, who have seen this? It's called the electricity map. Yeah, so 1, 2, few. Okay, good. Okay, more. this shows how much each country and each region in the country actually how carbon intense their energy production is. France again is quite green. Normally it's quite green because of nuclear energy. Nordics are very green, mostly because of hydro. Other countries are on different scales. This is all Europe. Europe is quite okay. The US, for example, is quite terrible. Most of places it's quite terrible. Most of the world is not green. It's still generating a lot of emissions to generate energy. Now, there's this sort of a naive way of the forced way that typically companies approach sustainability in IT. They say, if I move my loads to France or to Norway, then I become greener. This is sort of correct. The problem is that you don't see it on this map, but if you go to actually you can see it. There are arrows here. So when you move your load from Netherlands to Norway, what actually happens is that you take their green energy and then they don't stream it back to Norway because all the additional energy they don't use in Norway, they just stream it to Netherlands, right? So if you move your loads from Netherlands to Norway, it really doesn't matter that much because then they will just stream less energy back to Netherlands. So moving around loads is not automatically helping to reduce overall emissions, but it may help you to look greener in reports. So this is carbon, sort of related to carbon awareness, to basically how green the energy is. Also, this is somewhat problematic because it's not always considering how green a specific data center is. Because if a data center is in France, it's not automatically connected to the central grid. It may use its own generator, so its own solar energy. So it's not automatically the same as the grid around it. But still, the biggest problem in IT is still very poor utilization of what we already have. Right, so what basically happens is that we use less than 20% of the IT capacity we already have. Right, so this is one of the examples. There are many pieces of research around it. It varies between 10 to 20% of the capacity utilization. Right, what it means is that we basically throw away 80% of what we already have. So this is the biggest challenge in IT today. That's why most of the reduction of the emissions, in our experience, comes from just shutting down unneeded things. So reducing or removing zombies, right-sizing, removing things that you're not using, removing unneeded test environments, and all kind of other things. So there's actually quite easy way for almost any company to reduce emissions by about 50% or even 70% without much effort. This is the tool we built, open source, to actually measure that. I'll not focus on that. So unfortunately, in most companies today, this is not first priority. And this is a bit of exception here in France, which is, again, a few months ago, we sort of accidentally discovered that in France, there is additional regulation that actually is practical and encourages or actually forces companies to reduce emissions. And this is, we haven't seen this anywhere else, right? Everywhere else, the current level of regulation is about reporting. So companies have to report CSRD, they have to produce the numbers and calculate their emissions on not very accurate way, but it doesn't really matter if they reduce or not. They just need to report the numbers. As far as I understand, in France, the regulation actually sets specific goals, which is quite unusual. I think this is the only country in the world where this regulation exists. So, but everywhere else, it's basically not highest priority. I'm not sure how high priority is it here, is it? How much companies actually actively invest in reducing emissions? Who invests, like, whose company invests a lot and cares about, like, top priority? Anyone? Okay. Normally, it happens, but normally those companies are ideologically committed to this. So they want to do it not because they have to, but because it's important for them. They want to save the world. Who doesn't do anything? Whose company does absolutely nothing about emissions? Okay. Normally, it would be the rule, the like majority of the company of the attendees. So the problem is that it's not really enforced by the regulation, and there is no immediate benefit from it. The benefit is from reputation. So you can say that you're green, and then customers hopefully will buy more from you. But you can just say you're green. You don't really need to do anything about it, unfortunately. It's enough to just say it. There's more and more regulation to reduce greenwashing, but it's still quite easy to go around it. Okay, so that was all higher level and IT in general. What about AI? What's the actual impact of AI? Who thinks that AI is like green? Yeah, quite ridiculous, right? It's not green. No, it's not green, and it's quite dramatic, the impact of AI on emissions. So Google and Amazon and Microsoft and all the Meta specifically, they all been on the way to net zero. They overcommitted to that. They all promised that by 2030 they will be net zero, and this is the result with the addition of AI. Microsoft added 30% to their emissions in the last couple of years. Google 50%, Amazon don't say, but it's also increased. It's quite dramatic, right? This is absolutely, almost entirely due to AI, right? Because there's not much change compared to anything else those companies do, except the additions of GPUs and massive scale AI systems. Now, just sort of not to go too deep into AI, which maybe some of you would want to, but just a very, very high level. There are 2 points in AI that actually are relevant, right? There are 2 major stages. One is the training. That's where we train the models, right? We generally know that those are quite intense. And the second one is inference. Inference is when you use a model and you add your own data and jointly you generate the result, right? So when you ask ChatGPT, there is a pre-training of the ChatGPT 4, for example, model, and then there is inference. That's where you enter your question, which goes to the model and gives you back the answer. So it sounds like training the model is a big deal, right? That's those numbers. This is mostly about, actually, there's a quite specific number. So this is a footprint of so this is Meta's AI. In 1 week, they're basically using, this is a weekly number, this is for a year, 5.4 gigawatt of energy. Now, I'm not talking here about carbon intensity of that energy. It very much depends where the data centers are located, and they're located in different places. So it's actually not that trivial to decide if this is green or not. Actually, no. That's an easy answer. It is not green, but some of the data centers are greener than others. Basically, they are saying that they are using 5.4 gigawatt of energy, and that is like running a full nuclear reactor for 6 hours. And this is just to train the Meta's model, and they are saying that they offset all these emissions. Now, who have actually any of your companies using offsets. Have you heard about offsets? Okay. The general idea of offsets is that you can buy offset credits, so from a company that, for example, plants trees or reduces carbon from sea, all kind of different things. So they're removing the emissions or preserving the forests and stuff like that. And you can buy from them for the price of about below $80 per ton of emissions. So if you emit a ton of carbon equivalent, you can pay somebody $80 and they will give you a certificate that says that you basically, you're even now. In reality, different calculations suggest that the real price of reducing a ton of emissions from the atmosphere is about $1,000, not 100, not an 80. And in some cases, you can buy it for as low as $5. Like for example, when you fly, you can pay like $5 extra for the ticket, and they say they remove the emissions for the entire flight, which is, if you watch this video from John Oliver, this is just 20-something minutes. It's really, really nice and clearly explains how terrible the offsets are, right? They don't really help. And also there is not enough space even to plant all these trees to remove all these billions and billions of kilograms of emissions from the atmosphere. So this is not really a viable solution. Right, so we understand the training stage is actually, it uses very heavy GPUs, uses a lot of energy, a lot of hardware, and they run for weeks and months sometimes. So it's obvious that they actually generate a lot of emissions. What about inference stage? Right, so that's where we just ask a simple question from ChatGPT, right? Would that be a significant impact? So without going into too much specifics, you obviously cannot see it, but the general idea is that in just a week of ChatGPT with 100 million users, they use 3.5 gigawatt of energy to just answer those questions. Right, so the point is that, yes, the training is actually very heavy because it's one heavy, long process that uses thousands and thousands of different GPUs, but inference is actually also very heavy because of the scale, because there are millions of users. And each call is actually using a bit of energy. It adds up at the end. Another good example is that this is a calculation by from a university. They roughly calculated what it would take to use, if Google would use AI for every query you are asking on Google search, right? Without going too much into details how they did it, but the result is, it's about 22, almost 23 terawatt of energy a year, which is comparable to about Ecuador or Ireland. Just for one company, just for one product Google search, if every search query would go into Gemini, that's how much energy they would use. The total energy of the world is 24,000 terawatts. This is about 0.1%, which is for one product for 1 year. Now, we keep talking about emissions, which is probably the most important thing, but there are other things. For example, water. Now, if you think that it's actually nicer to move our loads to a sunny place because we assume that there's more solar energy there and it's cheap and it's green and everything, right? But those places likely also have little water. But if you put a data center, it consumes water for cooling and for all kind of other purposes. So actually you are using the water that is needed in that particular region. So it's always a trade-off, right? Cheap green energy comes at the cost of very expensive and not easily available wood. The same story is with rare metals for batteries and other things. Okay, so is it worth it? Yeah. Is it worth to actually use all this energy to have UI? Because so far it was all very scary and terrible, right? Actually, AI is a good thing. It could be a good thing. This is an organization called AI for Good. They list a lot of amazing initiatives where AI is used, right? So autonomous cars, distributed energy grids, all kind of different things that AI can help a lot, right? AI is amazing in collecting massive amounts of data and making conclusions. This is exactly what helps to reduce emissions from different industries and create new technologies to reduce emissions. So actually, AI will help us to reduce emissions by using it in the right way, in ethical way. Generally, there are few areas that it can be used. So first, efficiency gains, right? When we use things, for example, if you have, we work with a company that is a logistic company. They have 200 trucks, and trucks, they are going and delivering pallets of stuff. It's understatement to say how inefficient they are, right? So the routes are not well planned. The pallets are not well. Imagine like you are an IT system and you have 10 VMs or 200 VMs, and they are all 5% utilized. It's not unusual for IT setup, right? So trucks are sort of the same. They are not very well utilized and they are not driving in the most optimal routes. What it means is that they're burning a lot of diesel fuel. And if we use AI, we can reduce that. We can help them to actually be much more efficient. We can reduce it by tens of percent. There's a lot of health advancements related to AI. There's hundreds, thousands of different AI startups that are using AI to actually develop new technologies to save lives and reduce emissions. And so there's also, generally speaking, AI is the next generation of, it's like the next industrial revolution. It will help us to build new value, which means it will, theoretically, will help people to be richer. It can do anything better or worse, right? If you have a bad thing, AI will make it worse. If you have a good thing, it will make it even better, right? It's automation on steroids. It will increase the same thing you already have. Again, if you're producing a lot of t-shirts for no good reason, it will help you to produce even more t-shirts, right? Is it helpful? Unlikely. Yeah, but if we apply it to good causes, then it will help us to save the planet. Now, how we can reduce actually the impact of the bad side of AI? Again, it's about energy efficiency, hardware efficiency, and carbon awareness. So we want to use less energy, we want to use less physical devices, and we want to run the things in place where the energy is green. So on high level, there's 4 points that we can do that. So first, we can use renewable energy sources. Now, again, you can sort of say how I am when I'm running a training model, how can I use greener energy source? You can, by running the loads in the places where the green energy is available. For example, during the day, normally we, based on the history, we sort of we are used to run heavy loads at night. So actually today, if you want to get solar energy, it's better to run them during the day. But even that depends. If we can adjust the loads to availability of greener energy by looking into where and when green energy is available, then we can reduce the impact, sort of smooth the consumption of greener energy and this way reduce the emissions. There's efficiency gains, there's policy regulation, and a lot of hardware innovation. So now, without going into too much details, but there is a lot of, on technical level, there is a lot of things, when we train the models and we use the models, there's a lot of things that we can actually do. So pruning, like reducing the size of the models, reducing the size of the data elements to, for example, from 32 bits to 8 bits or even 4 bits. There's a lot of things that we can do specifically to optimize the execution. This is not different from optimizing any other software development. There's a lot of work happening around optimizing hardware specifically for AI, specifically for use cases, certain use cases in AI to reduce the energy consumption. And sort of at the end, the question is it really so what can we do actually to practically today to reduce the emissions of the AI systems? So I think first and more than anything else is you ask yourself, do you actually need AI? Yeah? So the greenest thing with AI is not to use it. Now, obviously, we want to use it if we need it, right? If it solves a problem that other solutions don't solve. But if it doesn't, then it just generates a lot more emissions and a lot more work. So if you don't actually need AI, don't use it. It's complex. It's heavy on energy. It's heavy on all kinds of things. But then don't train your own models. If you have quite good models that are already available, like Llama, you don't actually need to use your own models, right? That will save the training of the model. And it also doesn't have to happen every month or every year. It could happen once in a while. Maybe once a year is okay. Again, not every problem should be solved with AI. All standard algorithms are good enough often, right? The fact that you're struggling and solving a problem with normal means may just be that you need to, invest a bit more time into improving your ways of development. It doesn't have to be AI. Yeah, and at the end, is it good or bad? It depends. Right, there's a lot of good things that AI may bring. It may solve the difficult problems that we have with finding right minerals in right places, to find solutions for difficult medical and other problems. And on the other side, it has the cost of emissions and energy consumption and everything else. So at the end, like every other technology, it's a trade-off, right? So our responsibility as users of this technology is to make sure that we use it in ethical and responsible way and reduce the emissions, at least until we have alternative technologies that are not alternative energies and alternative data centers that are not as heavy on emissions. Yeah, I'll skip that. The last, I promised to answer that question. That's it. So how bad bananas are? Okay, actually, bananas are good in terms of emissions. Why they're good is because it depends how you measure. So this book measures food in terms of alternative foods, meaning number of calories consumed by a human. If you compare it to the worst foods, actually the worst food in the book is airlifted asparagus. They're like dramatic amount of, there's like thousands and thousands of Do I have it? I don't have it. But bananas are good as food goes. So the amount of calories you get from a banana compared to beef or pork is actually good. So generally, beef and pork are the worst, except air-flown asparaguses. Everything that is growing is better than meat. And then just maybe last thing, let's say cryptocurrencies. In 2019, and that's lower than today. Today it's more than that. And cryptocurrencies contributed about 1/12% of carbon emissions of the entire world. Right? Mostly it's mining, right? But cryptocurrencies, 1/10%. You think it's not a lot, but it's actually enormous amount. 1/10% of the entire world carbon emissions came from cryptocurrencies, which is, I'm not saying cryptocurrencies are useless, but cryptocurrencies mining is effectively useless exercise, which generated 68 million tons of CO2. Right, so this is a good example of just don't do it. That's the greenest way to achieve it. And these are some examples of books that I liked on the topic. I think if you are interested about the topic, the best book to read is from Bill Gates, How to Avoid Climate Disaster. And if you want to read a technical book, then Building Green Software is the best one. That's it. Thank you.
Take one or two questions, short time.
Yes.
Okay. So we are going.
First is hard. Yeah.
Hi, there's
one question.
Yes.
At the beginning of the presentation, you said that there was increasing IT demand, which was almost exponential.
Yeah.
And then little decreasing by CO2 footprints.
Yes.
And if we do all optimization that you explained during the presentation,
we're not going to achieve that. No.
No.
Yeah.
Okay. That's what. So,
no.
So yeah. There is no solution for that.
No. So the general idea is this. I think also the book's actually quite good in explaining this. So what we need is two things. One is create new technologies that will replace existing technologies that will lead us to net zero. I mean, arguably nuclear reactors, maybe fusion nuclear reactors or whatever, right? I don't know. They may take 50 years or maybe never, right? But there are, we can also create technologies like I saw companies were extracting carbon from the sea or putting it back into the sea. And so there are a bunch of technologies, but they will take decades to develop. So one thing is we need to continue investing in those technologies. For example, getting the data centers much greener, liquid cooling, solar panels. So eventually the data centers will be very green, but it will take decades. The second thing we need to do is to reduce emissions until then. That is mostly done by optimization of what we already have. So if we are wasting 80% of our capacity, that's not very smart, right? And it takes energy and it takes other resources. It's also very expensive for no good reason, right? So, so two questions. One, in 20 years, are we close to zero? And the second question, how much did we emit until then? Mentioned is mostly focusing on the second part. The fourth part requires entirely new set of technologies. Yes?
Actually, I have two questions, and thank you so much for the talk. Do you have like some practices, like day-to-day practices that you can put in practice to achieve like consumption?
Yeah.
But not just like limiting the overall consumption of energy. And second one, just like how much does the banana consume then? Like in terms of
It's about 100 grams of carbon equivalents per banana.
Okay.
whatever it means. I mean, there's a lot of, the good thing in the book is that there's a lot of comparisons to like email or a bike, or like going on a bike, feeding yourself bananas versus feeding yourself a burger, right? And what's the difference? Now, the specific practices, generally or in AI, specifically in, like generally IT practices, the most meaningful practices you have is shut down the lights when you leave the room, right? Roughly, yeah? So when you leave the room, you know, you tell the kids that you have to switch off the light because we are paying for them and they're bad or whatever, right? But if you compare it to IT systems, a lot of them stay alive for no good reason, like testing environment overnight. Why would you do that? Now, mostly because you're afraid it will not come up tomorrow. Or you don't have the time to invest in automation to shut it down and then start it up. All kind of things like that. It means that you don't have really good IT systems, right? You do need to invest in optimization, because this way you're not just saving the emissions, you also save cost, and you also create better systems. Because if you're afraid that the system will not come up tomorrow, it means it's poor quality, right? Because otherwise, why would you be afraid? So this is the most important thing. It's just shut down unneeded systems, scale down, not just up. That's what helps most.
Thank you, Penny.
Thank you.
Tu peux faire attention. Ah oui. Tu te présentes si tu veux. Alors, on va essayer déjà si ça passe. Je vais regarder ça. Et voilà. Alors bonjour à tous, je vais faire un lightning talk ultra rapide. Vous voyez, en fait, on va faire vraiment en mode démo live, donc on va essayer de ne pas avoir d'effet Bonaldi pour le coup. Qui a déjà entendu parler des Profile Guide Optimization? Personne. Un. Qui l'a déjà testé? Bon, alors comme ça, on va pouvoir vous montrer comment ça fait. Alors, le Profile Guide Optimization, qu'est-ce que c'est? C'est en fait un mécanisme qu'on fait au moment de la compilation des logiciels pour faire en sorte de les améliorer. Le concept, c'est qu'on va faire une boucle de rétroaction, c'est-à-dire qu'on va faire tourner le logiciel, on va récupérer la façon dont il tourne en production, et on va le réinjecter au moment de la compilation la deuxième fois pour faire en sorte que le compilateur fasse des optimisations meilleures. Globalement, donc là on va le faire en Go, on estime qu'à peu près on a une optimisation entre 2 et 12% en fonction du workload, en fonction de la version de Go, en fonction de plein de choses comme ça. Et là, on va essayer de faire encore plus, et qu'on va le faire sur Kubernetes, c'est-à-dire qu'on va mettre un binaire sur Kubernetes, on va voir comment il fonctionne, et on va recompiler instantanément derrière avec le guide. Pour aller plus vite, je vous ai déjà spawné un cluster Kubernetes, donc ça c'est fait. Ici, vous avez le run Terraform qui a été là. On a donc un kubeconfig qui est pré-généré, donc là c'est bon. Et là, ce que je vais faire, c'est que je vais installer Parka, ou Parsa, je ne sais pas trop comment il le prononce, qui est en fait un logiciel, il faut le runner 2 fois parce que le namespace n'est pas créé, qui va justement nous permettre d'aller débugger, donc ça fait de l'IBPF, ça récupère les binaires, ça récupère les endpoints de débugage des applicatifs. Donc il y a le serveur central et il y a après les agents qui vont se mettre en daemon set. Je regarde comment ça s'est passé, ça tourne, on est running, on a juste le serveur qui est en train de se lancer. Et là, ce que je vais faire juste un port forward sur en espérant qu'il arrive à tourner. Ah oui, il y a l'autre qui est encore. Ah oui. L'autre, il est en watch. Hop. Donc là, lui, voilà. Donc là, j'ai un port forward qui me permet d'aller sur le serveur par ça. Et donc, comme ça, on va pouvoir regarder comment c'est. Tac. Et vous ne voyez pas l'écran, et c'est ça qui est drôle. More sharing option, sharing something else. Et je vais partager tout mon écran, ça sera plus simple. Est-ce que ça arrive? Non, ça n'arrive pas. Si, c'est bon, voilà. Et donc là, vous avez le serveur, donc le serveur de debug qui va nous permettre de récupérer toutes les infos. Ce que je vais faire, c'est que déjà, je vais aller récupérer, je vais aller faire tourner un logiciel. Donc là, ici, on pourrait builder le logiciel avec le Docker build. Je l'ai déjà fait. C'est vraiment juste une démo. En fait, c'est quelque chose, on lui envoie un Markdown et il fait de l'HTML dessus. Donc juste, hop, j'ai créé la démo. Je vais créer le port forward qui permet d'aller dessus, mais il n'est pas encore running. Donc on attend encore un peu. Is not running, pending, pending. Ah, c'est sympa les effets comme ça. Bien sûr, ça marchait très bien. Et oui, parce que le cluster. J'aurais dû trop la taille de cluster, c'est ça? Non, c'est pas drôle. Les démos, c'est toujours risqué. Hop. Hop. Voilà, comme ça, vous pourrez voir que ça tourne comme ça. Mais en gros, donc l'idée, c'est que notre applicatif va tourner. On va essayer de lui injecter de la donnée. Grâce à ça, en fait, ça va créer un modèle. Je n'irai pas jusqu'au bout pour gagner du temps, mais vous comprendrez un peu l'idée qui est derrière. Je ne sais plus où est-ce que j'en étais. J'en étais par là. Donc, hop, on va réessayer de spawner, de regarder si la démo fonctionne. Est-ce qu'elle est encore en pending? Ah oui, c'est désolé. Ça marchait très bien tout à l'heure. Donc, je vais vous dérouler ce qui se passerait en théorie. Donc, en théorie, après, donc, on récupère un markdown qu'on va envoyer. Ce markdown, on l'envoie, donc ça fait de la charge. Après, derrière, on a un load tester. Donc, ce qu'il va faire, juste le load tester, c'est envoyer beaucoup de markdown. Ça va nous permettre d'avoir le load sur l'activité. Grâce à par ça ici, si jamais voilà, on a un peu de load, on voit ici que déjà, il a récupéré des informations sur des binaires. Donc, pas forcément sur le nôtre. En fait, il s'est plutôt examiné lui-même. Et en fait, on arrive avec ces traces-là, des flame graphs. Vous avez déjà dû le voir quand vous faites du debug. Là, l'avantage, c'est qu'on l'a par défaut. C'est-à-dire, on le met dans le cluster et on l'a par défaut pour tous les applicatifs. Ça vous permet comme ça de voir a posteriori quand il y a eu un problème, qu'est-ce qui s'est passé, quelles sont les fonctions qui ont été le plus appelées et où est-ce que potentiellement il y a eu un problème. Donc, ça permet de faire du debug a posteriori de quelque chose avant même que vous ayez eu le besoin d'activer toutes les traces de debug, etc. Donc, ce logiciel, en fait, vous permet d'avoir ça. Je vais tester avec lui. En fait, ce qu'il permet de faire, c'est qu'il permet directement de télécharger donc, ce qu'on appelle les PBProf. C'est justement cette trace-là d'usage, et c'est ça après qu'on va mettre dans le compilateur. Donc on va le récupérer, ça va faire quelque chose qui n'est pas du tout ce qu'il faut. Donc juste là, ça va être dans mon... Allez, télécharge-le. En théorie, ça fonctionne, bien sûr. L'effet Bonaldi. Après, en fait, on récupère ce profile en fait, ici qui a normalement été téléchargé. Je vais voir. Non, tout simplement, il n'est pas encore là. Mais après, en fait, on